Hello and welcome to this session. Learning Outcome LO2. Understand the effect of forces. Today we will learn how forces influence the world around us. We will look at how forces affect motion, shape, and stability, drawing on key ideas such as Newton's laws and their real-world applications. Through this, you will see how forces shape many aspects of everyday experience. In real situations, multiple forces act on an object simultaneously. The resultant force is the combined effect of these forces. If zero, the object stays still or moves at constant velocity. If not zero, the object accelerates in the force's direction. This concept connects directly to Newton's first and second laws. A force can increase or decrease speed and change direction. Newton's second law explains acceleration through force and mass. Larger forces or smaller masses result in greater acceleration. Forces also change shape, causing elastic or plastic deformation. Hooke's law describes elastic behavior in springs. Forces can cause objects to rotate around a pivot, known as moments. Moments determine if an object tips, balances, or stays upright. The principle of moments states that total clockwise equals total anti-clockwise moments in equilibrium. Load positioning and pivot placement are crucial. Balance can be disturbed or maintained by forces. An object in static equilibrium is motionless with balanced forces. Dynamic equilibrium occurs when moving at constant velocity with zero resultant force. Stability depends on the center of gravity and base size. A low center and wide base increase stability. External forces like wind can shift the center of gravity. Friction opposes motion between surfaces, while air resistance acts against motion through air. Water resistance affects motion in liquids. These forces reduce speed and generate heat, requiring more energy to maintain motion. Ignoring them in calculations leads to inaccurate models. Understanding these forces is crucial for accurate predictions. Forces acting over time change momentum, known as impulse. Impulse explains how airbags and crumple zones reduce impact injuries. By increasing the time over which force acts, the force felt is reduced. This principle is crucial in safety designs. Understanding impulse helps in designing safer vehicles and equipment. Balanced forces mean the resultant force is zero. A stationary object remains still, while a moving object continues at the same speed. Balanced forces do not cause acceleration or change direction. Examples include a book on a table or a car on cruise control. The object's state remains unchanged. Unbalanced forces result in a non-zero resultant force, changing motion. An object accelerates if the force matches the motion direction. It decelerates if the force opposes motion. Motion changes only with unbalanced forces. Examples include kicking a football or braking a car. Gravitational force is the attraction between masses. On Earth, it pulls objects downward, giving them weight. It causes unsupported objects to fall. This force acts vertically downward. Understanding gravitational force is essential for calculating weight and predicting motion. The normal force acts perpendicular to a surface, balancing weight. Friction opposes motion between surfaces, acting parallel. It resists sliding and can stop objects. Types include static and dynamic friction. Understanding these forces helps predict motion and design surfaces. Air resistance opposes motion through air, increasing with speed. Water resistance acts similarly in liquids. Applied force is any deliberate force on an object, like pushing a box. It can act in any direction. Understanding these forces aids in designing efficient vehicles and machines. Tension occurs in ropes or cables when pulled tight, acting along the rope. Compression squeezes objects together, found in columns and beams. It can shorten or crush materials. Understanding tension and compression is key in structural engineering. These forces ensure stability and safety in constructions. Upthrust is the upward force by a fluid on an object, enabling floating. It opposes weight, as seen in boats. Magnetic force acts on magnetic materials or charges, attracting or repelling. It doesn't require direct contact. Understanding these forces helps in designing floating devices and magnetic systems. Electrostatic force acts between charged objects, with like charges repelling. It acts at a distance. Centripetal force keeps objects moving in a circular path, always towards the center. Without it, objects move straight due to inertia. Understanding these forces is crucial in electronics and circular motion. A stationary object remains still if all forces are balanced. Weight acts downward, while the surface provides an equal upward reaction. No horizontal forces act. This results in zero resultant force. Newton's first law explains why the object doesn't move. A moving vehicle at constant speed shows balanced forces. The engine's driving force balances air resistance and friction. Resultant force is zero, maintaining speed. Motion changes only with acceleration, braking, or turning. Newton's first law explains this consistent motion. A ball on a smooth surface would roll indefinitely without friction. In reality, friction slows it down as an unbalanced force. A pushed book stops due to friction acting opposite to its motion. Newton's first law explains these real-world deviations. Understanding friction helps in designing smoother surfaces. Seatbelts apply unbalanced force to stop your body in a car. Without it, inertia keeps you moving. On a slope, friction can balance weight, keeping objects still. A steeper slope creates unbalanced force, causing acceleration. Newton's first law explains these safety and motion principles. In deep space, a spacecraft travels indefinitely without opposing forces. With no gravity or air resistance, the resultant force is zero. This is the purest example of Newton's first law. Understanding this helps in space exploration. It shows how forces affect motion in the absence of resistance. In summary, forces play a central role in shaping motion, stability, and the structures around us. Drawing on principles such as Newton's laws, we can understand how objects behave and interact. This understanding is vital in applying scientific knowledge to real-world situations, enabling the design of systems, products, and environments that are safer, more stable, and more efficient. If you have any questions, feel free to message us on WhatsApp at 07484361688. Our team will be delighted to help. Thank you, and see you at the next session.